All right, everybody. In this video, we're going to do a review of absolute value, and then I'm going to, probably pause it, maybe take about 3 or 4 minutes to review stuff, and then jump into some problems. So, without further ado, let's do a review. Rhyme fully intended there. Okay, remember absolute value, which is designated by these bars of something. Let's just say is equal to 6. Let's say we have that. Interpreting this, absolute value just means the distance, whatever's inside the bars, is from 0. So if I'm saying whatever number I have, it has a distance of 6 from 0, what you need to remember is that there are always 2 places where that can be, right? I could be 6 away from 0 right here, or I could be 6 away from 0 right there. Okay? I know we reviewed this, but the way that you're thinking about this is that absolute value is just measuring the distance, not paying attention to direction. You can think on the number line that this 6 right here has a positive direction and this 6 right over here has a negative direction. Absolute value doesn't care. It's just how far away could we run from 0 in either direction. And if I say that we could go 6, that means we could be either right here or right there. So what that just means is that every absolute value equation can be rewritten as 2 equations. And the way that it's done is in 3 parts. I want to just give you all 3 different possible ways that you could face an absolute value equation. So the first one, the easiest one, would be the absolute value of something is equal to some sort of number. Let's just say it's, 2, right? The second possibility is that we could say the absolute value of some sort of number is less than some sort of number, 2. And the third possibility would be the absolute value is greater than 2. Let's unpack how you would translate each one of these scenarios into a set of equations. For each one, anytime that you see absolute value, you know that you're dealing with 2 different either equations or inequalities. But let's unpack how you would work them. So here, for the first one, this is the easiest. What you're going to have here is if the distance of my unknown number is exactly 2, right, equals exactly 2 away from 0, well, that's 2 possibilities. That means you just take whatever's inside, you ignore the bars, you just set that x is equal to positive 2, or x is equal to the negative of whatever that number is. So that would just be negative 2. And then you just, you could solve for that. In this case, there's really nothing we can solve for because we didn't have anything cluttering up, our variable inside the bars. So we know that there's just 2 exact values. But supposing, here, let me give you an example of this. Supposing I said that I had absolute value of 2x minus 3 is equal to 6. Well, let's just, work this through. So stage 1, if we have equals, all we do is we take whatever's inside the bars, set it equal to that thing, and also set it equal to the negative of that thing. You are always going to have 2 equations or expressions whenever you're dealing with an absolute value. So the first one would be, well, we just take 2x minus 3 is equal to 6. We can solve that. The second one would be 2x minus 3 is equal to negative 6. And, I think you just do your standard algebra to solve for this. I'll try to do this quickly. So if I add 3 to both sides here, that gets us to 2x is equal to 9. And that means x is equal to 9 over 2. So, is equal to 4.5. There's that. This one, if we add 3 to both sides, we get 2x is equal to, well, it's a positive 3 plus that, so it gets us to what, negative 3? Yeah. X is equal to negative 3 over 2, or is equal to negative 1.5. So these would be the 2 different values of x that would satisfy this equation. If I plug those into the bars here, the inside would become either positive 6 or negative 6. Either one of those fits this. Both of those numbers are exactly 6 units away from 0. Okay? I know I kind of went through that a little bit fast. Make sure to pause the video, maybe review if that confused you. So let me clear this out and let's talk about the inequalities. All right, let's do this for a minute. Let's see here. I'll try to do this fast. Here we go. All right, now there's just a slight bit of a complication with an inequality. So let's just take this scenario here. If x has to be less than 2 units away from 0. Well, if you think about that, if I sketch that scenario here, let's think about what that means. So my number has to be less than 2, think about it in miles, right? Less than 2 miles away from my home base. Well, there's two different directions on a number line, so that would be either here or here. But since it has to be less than, we know that the number has to be somewhere in between, right? I can't be any further away than 2 in either direction, so I have to be somewhere, here, which I've marked. Well, let's think about how, just looking at what I just drew there, you could, ignoring the equation, or technically inequality, but you know what I mean. But if we just looked at this number line, how would you describe what are the range of numbers here? And hopefully this would make sense to you. I could say, well, that's just the same thing, that x has to be greater than -2, but also x has to be less than +2. This is the key to figuring out how to handle inequalities with absolute values. Here's what you do. Here's your master formula for this. Okay, doing this relatively quickly. If you have an inequality, what you do, step number 1, is you just remove the bars and write down, like pretend the bars aren't there, the absolute value bars, and just write down the first thing. So that would be x has to be less than 2. And notice that's this part right here. Check, check. Right? It has to be less than 2 miles in the positive direction away from 0. But then what you do, remove the bars and switch the direction of both of the terms here, right? So in this case, we have the inequality is saying less than, switch it to more than. The number there is +2, switch it to -2, and that's it. So the second part is switching the direction of both of these things gets us to x has to be greater than -2. And the same exact logic goes with this one. If the absolute value of x has to be greater than 2, think about if I sketch that, what that would look like. Do that pink. Well, that means, starting from 0, the distance away from 0 has to be more than 2. Well, let's say 2 is here, -2 is there. That means we are anywhere down that direction or anywhere up this direction, right? Because any point along that line in either direction is going to be more than 2 away from 0, but just in different directions. So think about how we would switch this. First thing we would do is number 1, just remove the bars and write the thing. X is greater than 2. Done. Then second equation or inequality is remove the bars and switch the direction of both of these things. So instead of greater than, make it less than. Instead of +2, make it -2. And there we go. And that's it. That, in a nutshell, is really all that you have to do with your inequalities. Excuse me, with the absolute value inequalities. So I'm going to pause the video and we're going to jump into a few problems applying these different principles.